Welcome to the DIY Honda Garage channel. Welcome to this troubleshooting guide on diagnosing DTC P2237-13, which points to an issue with the air-fuel ratio AF sensor, specifically sensor 1. The AF sensor plays a critical role in monitoring the air-fuel mixture entering the engine, thereby influencing performance, emissions, and fuel efficiency. Sensor 1 is typically located before the catalytic converter in the exhaust system, and it communicates vital readings to the powertrain control module, PCM. When the sensor or its circuit exhibits high voltage, it triggers DTC P2237, indicating an open IP circuit. In this guide, we will explore the error description, possible causes, symptoms, and specific troubleshooting steps to effectively diagnose and resolve the issue at hand. The error associated with DTC P2237 is centered on the air-fuel ratio AF sensor, specifically sensor 1. The AF sensor is essential for measuring the air-fuel mixture that enters the engine, ensuring optimal combustion. It sends this information to the powertrain control module, PCM, which adjusts fuel delivery for efficient engine performance and emission control. Sensor 1 is typically situated before the catalytic converter, making it crucial for monitoring engine operation. If the sensor or its connection experiences an open circuit, the PCM will store the DTC, indicating high voltage in the IP circuit. This condition can hinder the engine's performance and may lead to fuel inefficiency if not addressed promptly. The possible causes for DTC P2237 can be broken down into three primary categories. The first potential cause is an open in the IP circuit, which can occur due to damaged wiring or poor connections between the AF sensor and the PCM. A faulty powertrain control module, PCM, may also be responsible, as it is in charge of processing the signals from the AF sensor. Lastly, a defective AF sensor itself can trigger this DTC if it fails to operate correctly. Each of these potential issues could lead to an incorrect signal being sent, ultimately leading to high voltage readings and triggering the DTC stored in the vehicle's diagnostic system. The symptoms related to DTC P2237 can significantly impact vehicle operation. One of the most common symptoms is decreased engine performance, which may present as stalling, rough idling, or difficulty accelerating. Additionally, the vehicle may produce increased emissions due to improper air-fuel mixture readings affecting combustion efficiency. Often, the driver will notice an illuminated check engine light on the dashboard, indicating that a diagnostic trouble code has been triggered. Ignoring these symptoms can lead to further damage and inefficiencies in the vehicle, if not addressed promptly. The first step in troubleshooting DTC P2237 involves starting the engine and maintaining an engine speed of 3,000 RPM without load. This means the vehicle should be in either the park or neutral position to ensure there is no strain on the engine. It's important to hold this speed until the radiator fan activates, as this indicates the engine has reached a sufficient temperature and operates normally under those conditions. Once the fan has engaged, allow the engine to return to idle. This step helps verify whether the engine is operating correctly and whether the AF sensor is providing accurate readings during different RPM conditions. For the second troubleshooting step, you need to disconnect the AF sensor, sensor 1, connector, and the PCM connector B. Once disconnected, you will perform an IP open wire inspection. Before testing, ensure the ignition IG mode is turned off and the connections are secure. The objective here is to check for continuity and determine if there is less than 1 ohm of resistance across the wire to confirm that the IP circuit is intact. If higher resistance is found, it indicates an issue within the wiring or connections, which could be causing the high voltage signal. Rectifying any faults here is critical before proceeding to the next steps. The third step involves further testing after ensuring that both the A frequency sensor and PCM connectors are disconnected. Begin by performing the confirmation procedure stated earlier. Following this, you will monitor the output voltage of the A frequency sensor. With the engine running, the expected voltage should be around 0.2 volts or more. If the voltage is outside this expected range, it could indicate an issue with the PCM or a malfunctioning A frequency sensor. This test is critical as it helps isolate whether the problem lies with the sensor or the electronic control unit of the vehicle. If the output is abnormal, consider focusing on the PCM for any defects. In the final troubleshooting step, after confirming the conditions of the AF sensor output and the PCM, if the previous tests indicated normal operation, it is now essential to specifically inspect the AF sensor, sensor 1. If it is determined that all other inspection items are functioning properly, then the AF sensor itself is likely at fault. This step is vital for accurately pinpointing the source of the issue. It eliminates other components and narrows down the diagnosis, leading to a more straightforward fix. By this stage, you should have a comprehensive understanding of each component's role and the specific failure point that requires replacement or repair. After you have completed the necessary repairs, it is crucial to verify that the issue has been resolved. Start by clearing the diagnostic trouble codes from the vehicle's PCM using the appropriate diagnostic tools. Following this, conduct a test drive to allow various systems to operate and reconfirm the functionality of the AF sensor. While on the test drive, pay attention to the vehicle's performance and any warning lights. After the drive, check the PCM for any reoccurrence of DTC P2237. A comprehensive verification process ensures that the repairs were successful and the underlying issue has been rectified. To prevent DTC P2237 from recurring, it is essential to incorporate preventive maintenance into your routine vehicle care. Start by regularly inspecting the wiring and connectors associated with the AF sensor for any signs of damage, wear, or corrosion. Proper connections are key to ensuring the sensor relays correct information to the PCM. Additionally, consider scheduling periodic diagnostics to proactively identify any emerging issues before they lead to warning lights or performance problems. Keeping up with these maintenance tasks can significantly extend the lifespan of the components involved and keeps your Honda CR-V operating efficiently. In conclusion, diagnosing DTC P2237 effectively requires a thorough understanding of the AF sensor's operation, its connection to the PCM, and potential causes of an open IP circuit. The steps outlined in this guide provide a systematic approach to diagnosing the problem, ensuring each component is checked methodically. Regular maintenance and inspections can help mitigate the risk of encountering this DTC in the future. By following the outlined troubleshooting methods and being proactive, technicians can ensure that the vehicle remains in optimal condition, functionally and emission-wise. Always remember to clear codes and verify repairs to maintain a healthy engine performance. Please like and subscribe to the channel. See you next time.